morning children, and welcome back to your chemistry class. So today we are going to continue the chapter of electrolysis, and over here today we are going to study about what is electrolytic dissociation. Okay, so the electrolytic dissociation, it is the process due to which an ionic compound, it dissociates into ions in the fused state. Fused state, in other words, can be also called as in the molten state or in the aqueous state, and this is called as electrolytic dissociation. Okay, so what did I say? What is electrolytic dissociation? The process due to which an ionic compound dissociates, okay, into ions in the fused state or in aqueous solution. It is called electrolytic dissociation. Followed? So let us understand the electrolytic dissociation of sodium chloride. Okay. Now, solid sodium chloride, it is an electrovalent compound, right? Why? Because it is made up of a metal and a non-metal, and its crystal structure, it also contains ions. What are those? That is sodium positive ions and chloride anions, right? So in solid state, this chloride ions, they are not free. Why are they not free? Because they are held together by electrostatic forces of attraction, and hence it does not conduct electricity due to the absence of ions. I hope this is very clear to you. So let me write it down so that it is more clear to you. So in solid state, sodium chloride ions are not free, but are held by an electrostatic force of attraction. Is this clear? So it does not conduct electricity. It does not conduct electricity. Why it does not conduct electricity? Because it does not contain ions, or we can also say because there is absence of ions. It does not conduct electricity due to absence of free ions. Is that clear? So one point is very clear, that in the solid state they will not allow electricity to pass through. But then what happens in the molten or in the fused state or in the aqueous state? So when sodium chloride, it is dissolved in water, then we say that it is in this aqueous state. So NaCl, when it is dissolved in water, then what do we call? It is in the aqueous state. Okay, and when it is melted, then it is called as the fused state. Is this point clear? Or in the molten state, right? So let us understand what happens in the aqueous state. In the aqueous state, what happens? That slightly negatively charged oxygen atom of the water, that is the polar water. Polar water is a polar compound, if you remember. It exerts a pull on the positively charged sodium ion. This I had explained you yesterday also. There's a charge over here and there's a negative charge, and there is lot of force of attraction between the two. So when this is added to water, since it is a polar compound, it also has a positive and a negative charge over here. So as I said, what, that the slightly negatively charged oxygen atom of the polar water molecule, it exerts a pull where, on the positively charged sodium ions. Similarly, a pull is exerted by the slightly positive charge over the hydrogen atom of the water on the negatively charged chloride ions. Thus what happens, that the ions, that the sodium and the chloride ions which were held by strong electrostatic force of attraction, it becomes free in the solution. These free ions, they then conduct electricity. They become free ions and therefore can conduct electricity. So always remember that the current can easily flow in the aqueous state. Why? Because of the presence of free ions. Now let us talk about molten state. In molten state, what happens? Very high temperatures, okay, like there is sodium and chloride, okay. So very high temperatures, they are required to melt the solid. The bond gets weakened between the sodium and the chloride ions. Hence, this provides free ions, okay, and therefore it will allow electricity to pass through. Now, this was about dissociation. We are now going to understand ionization. Let's talk about ionization. Okay, there are certain covalent molecules which are not at all made up of ions, but they form ions when they are dissolved in water. Okay, so these kind of solutions, they conduct electric current. So what did I say? How can we define what is ionization? It is the process by which polar covalent compounds are converted into ions in water solution is called ionization. Clear? So let us take an example of HCl. So HCl, first point, in gaseous state or in its pure liquid state, this is an unionized compound, okay, and it will not conduct electric current. So I'm writing it down over here. HCl in the gaseous state is an unionized compound and therefore does not conduct electric current. I hope this is very clear to you. Okay. Then second point about it. It becomes polar covalent in nature. That is, it shows the charge distribution in its molecule. That is, hydrogen is going to possess a small positive charge and chlorine will possess slight negative charge over it when it is dissolved in water. Clear? then it is going to, or in other words, we may say that now when it attains small positive and negative charges, we say that it is now a polar covalent compound. Is that clear? As I had earlier suggested, polar means it contains slight positive and the negative charges over itself. Then third point, when this hydrogen chloride it is added to water, that means it becomes a polar solvent. When dissolved in water, becomes a polar solvent, then slight negatively charged oxygen atom of the water, it exerts an electrostatic pull on the slightly positively charged hydrogen ions present in the molecule. So look over here, there is a slight positive charge and the slight negative charge when it is dissolved in the water, which also contains a slight negative charge on oxygen and hydrogen. There are two atoms, so a slight positive charge is found over them, right? And hence when this HCl is dissolved in water, what is it going to form? It forms hydronium ion. And what is hydronium ion responsible for? Conducting, because it is a charge present over here, and chloride ions are formed. So now over here positive ion and a negative ion is formed, and hence it will allow electricity to pass through. Secondly, the formation of hydronium ion is also an indication that HCl is acidic in nature, right? So the H ions, when they combine with water, they form the hydronium ions, which gives us two important points. What is that? That HCl, it is acidic in nature. Secondly, ions now, that is the hydronium and the chloride ions are present. So now it will allow electricity to pass through it. I hope ionization is also very clear to you. Now let us understand the difference between ionization and dissociation. Difference between ionization and dissociation. It is very simple but very important also. So whatever we have studied, this is just the summary of it. So what is ionization? It is the formation of positively or negatively charged ions from the molecules which were not initially in their ionic state. Okay, so formation of positively or negatively charged ions from molecules which are not initially in the ionic state. Clear? Whereas what is dissociation? It is the separation of the ions which were already in their ionic compound. Separation of ions which were already present in an ionic compound. Okay, then what is the second difference between the two? The polar covalent compounds, they always show ionization. Okay, polar covalent compounds show ionization. Example, can you give me? Example could be like your HCl, it could be like your NH4OH and so on. Okay, whereas electrovalent compounds, they show dissociation. Electrovalent compounds show dissociation, right? Example could be like your KCl. On dissociation or passing current, it will form K plus Cl minus. Okay, so this was the difference between ionization and dissociation. Next, let us now understand the electrochemical series. Okay, this is important, which is also called as EC series. Okay, so metals, you already know that they lose electrons from the outermost shell of the atoms, and what do they form? They form positive metallic ions. So I write over here, metal elements lose electrons from the outermost shell of the atoms, forming positive metallic ions. Okay, for example, like potassium, loses it loses one electron, and what does it form? A metallic ion. Similarly, calcium will lose two electrons and will form calcium ion. Okay, this can also be written like this: potassium ion plus one electron. Okay, another way of writing it down. Then for calcium, it can be written as Ca2 plus 2E minus. So the tendency to lose these valence electron, it varies from metal to metal, right? The metallic elements, they can be arranged hence in the decreasing order of their tendency to lose valence electrons, and this is termed as electrochemical series, right? So let us today understand the electrochemical series of the metals and non-metals. Now let me write down the electrochemical series of metals over here, then it will be easy for you to understand. So let's see, like I'm writing down the metals, then elements over here, and then their cation formation. I hope you know that, but still I'm mentioning it over here. So highest is potassium, it will form potassium ion. Then it is calcium forming calcium ion. Then sodium forming sodium ion. Magnesium forms magnesium ion. Aluminium forms aluminium ion. Are you getting my point? Zinc forming zinc ion. Then iron is there after that, forms Fe3 plus. Then nickel is there, forming Ni2 plus. Then tin, lead, tin forms Sn4 plus. Lead forms Pb2 plus. Then after lead comes your hydrogen, okay, forming H plus. Below hydrogen, what do we have? We have copper, mercury, silver and gold, platinum, all that you know. So copper forming copper ion, mercury forming mercury ion, and so on. So sodium, it can easily get converted into sodium ion, much more easily than the copper into copper ion. Okay, there also zinc becomes zinc ion more easily than your silver becoming silver ion. I hope this point is clear. So based on the ease with which the atoms of these elements, they lose electron and they form these positively charged ions. These metals, they have been arranged in this form of series. So if you remember your electrochemical series, somewhat related to it, not exactly, but you can easily remember it. Now, talking about this electrochemical series. So all the metals with a higher position in the series, they always displace the one which are at the lower position. This point you should be knowing. Then all the metals which are placed below hydrogen, they cannot displace hydrogen from the acids, while those above it, they can easily displace hydrogen from the acid. Then elements which are lower in the series, they get discharged more easily. Where do they get discharged more easily? At cathode, okay, during electrolysis. Why? Because cations, they gain electrons. Fine. Then these metal atoms which form their ions more easily, they accept the electrons to form the atoms with the greatest difficulty. I repeat this point. What did I say? All those metals, right, which form their ions more easily, they will accept the electrons back to form the atoms with more difficulty, right? Thus, sodium, if we compare sodium and copper, which one is going to form the ions more easily? Sodium is going to form more easily than copper. So, it will find it more difficult to take back that electron and form the atom. I hope this example is clear. Then next, hydrogen has certain properties of a metal as well, and therefore this hydrogen is also said to show dual nature. What is dual nature? That though it is a non-metal, but it is present in this series. Why? Because it also exhibits some properties of metals, right? Thus this position among the metal, it confirms about its identity with the metals, and it has been therefore placed in this series. I hope the metallic series is very clear to you, or in other words I should say the electrochemical series of metals is very clear to you. Now let me talk about the electrochemical series of the anions. So firstly let me write down for the anions and then I will explain you. Okay, so let me write here anions. So sulfate ions, nitrate ions, then chlorine ion, bromine ion, iodine, and then OH minus. Okay, so what do we understand over here? Anions, as you know, they are negatively charged ions. On electrolysis, they move towards where? Anode. This I had already explained to you yesterday. What do? They lose their extra electrons or the negative charge at the anode and they get discharged there. But remember, all anions, they do not have identical tendency to lose electrons, right? Thus, based on the tendency to lose electrons and get discharged at anode, these anions have been arranged in the increasing order. Okay. So let us understand, lower the position of an anion in the series, more easily it gets discharged at anode. So which ion? Hydroxide ion or bromine ion? Which one is going to easily get discharged at anode? Definitely hydroxide ion is going to easily get discharged at anode. Higher the position of the anion in the series, more difficult it will be to lose electron and get oxidized. So as we go down, what happens? It increases the ease of discharge at anode. Fine. So we stop over here. Next time I shall come back to you with the selective discharge of ions at electrodes. Thank you.